Hi students, today we are going to discuss about the air pollution. We are discussing about the air pollution, you can remember. Today our lecture number is 11 and module is 2. Okay, so this is the subject name, that is environmental science. The subject code is, as you know, MC301 and 401. The contact hour is 24. These are the some of the course objectives. You can understand the natural environment and its relationship with the human activities. You can able to apply the fundamental knowledge of science and engineering to assess environmental and health risk. You will be able to understand the environmental laws and regulations to develop the guidelines and procedure for the environmental health, for the safety of the environment and safety of yourself. And also you can able to solve some of the scientific problems which is related to the air pollution, related to the water pollution. Okay, so related to the sound pollution. These are the some of the course objective. Now we have the course outcome. So to understand, after finishing this course, you can understand the relationship with the environment, the human activities with the environment. You can also apply your fundamental knowledge of science and engineering to assess the health risk and environmental risk. You can develop some of the guidelines and procedures and also maybe equipments for for safety of the health and and also the which is obeying the environmental laws and regulations. And after this course, you can acquire the skills of the scientific problem solving related to the air, water, sound pollution. Okay, so these are the some of the course outcomes that we have. This is the lecture plan of the air pollution. Yeah, so these are the some of the objectives of today's class. So today we will discuss about the control of air pollution by using some of the equipments like gravitational settling chamber, the cyclone separator, the ESP, electrostatic precipitator. Okay, so these we will see what is the fundamental, what is the principle, how they are working, what is the fundamentals of these equipments, how they are working, how they can to purify the air, how they can control the air pollution. Okay, all this we will see. So these are the some of the topics that we will discuss. So this is a recapitulation. In previous classes, we have discussed about the ambient lapse rate, the adiabatic lapse rate, atmospheric stability, and also we have discussed the main points, that is the acid rain, ozone layer, and smog. These are the some of the important topics that we have discussed in previous classes. Yeah, so this is the acid rain. Generally, if we in our environment, if we have excessive amount of sulfur dioxide, excessive amount of nitrogen dioxide, that time in our with the help of, they are attaching with the water molecules and they are forming the sulfuric acid, or they are forming the nitric acid. Okay, while it's raining, that time what will happen, the pH of that rainwater will be acidic. So this is called the acid rain, and which is harmful for all living system and also non-living systems, also having some of the harm detrimental effect like corrosion. Okay, so generally the acid rain, these are the some of the reactions that we have in the acid rain. What will happen, the sulfur dioxide will produce, first of all, the SO3. With the help of oxygen, it will produce the SO3. That SO3 will attach with the water molecule and it will form the sulfuric acid. Okay, again the nitric acid will attach with the water molecule and it will form the HNO3. The carbon dioxide Again, excessive amount of carbon dioxide will attach with the water molecule and it will form the carbonic acid. So these are the some of the reactions that we have incorporated into the acid rain. Next, the causes of acid rain. Generally, in the acid rain, the sulfur dioxide and the nitrogen dioxide will be the main contributor. Okay, they are contributing more towards the acid rain. So this is the you can see this is the reaction how the sulfuric acid is forming with in presence of sulfur dioxide and water molecule. You can here also see with the help of the oxides of nitrogen, the nitric acid also, nitrous acid and nitric acid also will form into our environment, which is harmful. Okay, so what are the effects of acid rain? This acid rain will affect the plants, will affect the will affect the humans, and also it can affect the all type of aquatic animals. Okay, so the plant generally what will happen, this acid rain can dissolve all type of toxic minerals, all type of toxic compounds, and which will be absorbed by the plant's root. So this is harmful for the plants. Now for the aquatic life, what will happen, the if the acidity will increase, the results in mucus forming in their krill, which prevents them from absorbing the oxygen from the water, and that is very harmful for them. For the humans also, we can have the respiratory problem, the asthma, we can have the dry coughs, headache, throat irritation. All this are causing due to the presence of the acid medium in our rainwater. So these are the all effects of the acid rain. Now this is the ozone layer depletion. Generally, ozone layer depletion is mainly what is the compound, that is the CFC, chlorofluorocarbon. Generally is the main responsible compound, and where it is used generally in the compressor like fridge, like AC. Okay, so cooling machines, all type of cooling machines, so they are emitting continuously the CFC, the chlorofluorocarbon, and which will react with the ozone molecule, and it will dissociate into oxygen molecule and oxygen atom, and thus ozone also creating, and which is very harmful, because this ozone layer will protect us from the UV radiation. Whatever we are getting from the solar energy, they can absorb the UV radiation and they can protect us. Okay, if there will be the holes in the ozone layer, then that will be very much harmful for us. So this is the reaction and actually incorporating with the ozone layer. You can see here chlorofluorocarbon is the main compound, which is which can which can decompose this ozone into oxygen molecule. Okay, yeah, these are the some of the effects of the ozone layer, that is skin cancer. We can have eye and lung irritation. We can have it is also reduce the rate of the photosynthesis, which is again very harmful for the plants. It can affect the crop productivity. Okay, so smog. What are the smoke? Actually, smoke and fog, while attached with each other and at a time, they will called by the smoke. There are two types of smoke. Generally, we have one is industrial sulfurous or London smoke, and another one is photochemical smoke or London smoke. Okay, so the differences between these are the some of the differences between photochemical smoke and the sulfurous smoke. Generally, the photochemical smoke, the pan is the main reagent. This is the harmful reagent, and for the sulfurous smoke, generally the sulfur dioxide is the main reagent. Okay. So photochemical smoke, generally reaction is taking place in presence of light energy. Okay, and this may not proceed through the free radical mechanism, or it doesn't need any light energy. So this is the oxidizing type of the photochemical smoke is the oxidizing type of smoke, and this is the reducing type of smoke. So these are the some of the examples, some of the differences between the photochemical smoke and sulfurous smoke we have. Okay, this is the reactions which is incorporated with the photochemical smoke. And now today we will discuss about the control. Okay, how we can control all these pollutions, because these pollutions are very harmful for us. So our main objective of control the main objective of control equipment, using the control equipment, is prevention of nuisance, prevention of physical damage to the property, elimination of health hazards to the plant personnel, whatever from the industry, from the factory, whatever we are getting the hazardous gases, okay, hazardous chemicals, that all can be eliminated by this control equipment. Okay, and recovery of valuable waste product, minimization of the economic losses, and also improvement of the product quality. So these are the some of the objectives of our using the control equipment. Okay, so what are the types of generally particulate control equipment that we have? That is gravitational settling chamber, that is fabric filter or baghouse filter, also we can call it by this. We have the scrubbers or wet scrubbers, also we can call it cyclone separator and electrostatic precipitator. Okay, so these are the some of the control equipment that you have in your syllabus. Now efficiency of a separating device, how we can measure the this is the eta, and that is the this is the equation. Okay, by this equation we can know the efficiency of a separating device, okay, or control device, whatever equipment we are using. Now first of all, we have the gravitational settling chamber. Now gravitational settling chamber, that means what will happen, we are using here gravitational force. Okay, so this is a chamber, you can see through this chamber the polluted air will pass. Okay, and this chamber is a large chamber, so while the gas will enter into this chamber, the velocity will decrease. Okay, and thus it will have the chance to settle down whatever dust particles, whatever bigger large particles we have, that all will be settled down. And this is the dust hoppers. Okay, and here, from here we are getting the pollutants, and after all, while from the outlet, whatever air we are getting, that is free, to some extent free from the dust particles, the large particles. Okay, so it is used to remove particles with size greater than 50 micrometer. The velocity of the flue gas reduced in large chamber. While the dirty gas will enter into this chamber, the velocity will decrease. For that, the gas particles will have the chance to get settled down. So whatever dust particles, whatever pollutants we have, the large particles pollutant, that will settle down into this dust hoppers. Okay, so particles settle under the gravitational force. Yeah, by using the gravitational force, all particles, the pollutants, we can settle down. Okay, yeah, what are the advantages and disadvantages of this gravitational settling chamber? That is a low initial cost, that is very cheap, easy to design. Exactly, the equipment is very easy to design, low pressure drop, low maintenance cost also we have, and dry and continuous disposal of the solid particulates. So these are the some of the advantages that we have for using the gravitational settling chamber. But still we have some of the disadvantages also. What are the disadvantages? That is, require large space. Yeah, the settling chamber will be very large, so that the volume, the velocity of the gas molecule can be reduced. So that is why also we require the large space. Okay, less collection efficiency. Yes, the efficiency, collection efficiency is less, and only larger size particles can be collected, as by the gravitational force the dust particle, the large particles will be settled down. That is why the particles must be large size. Okay, so only larger size particles can be collected here. Understand? So these are the some of the advantages and disadvantages for using the gravitational settling chamber. Now, why we can apply this gravitational settling chamber? For the industrial application is limited, used widely for the removal of large solid particles from draft furnace, from kilns. Okay, sometimes it will used in process industry, food industry, and also metallurgical industry. It is also used as pre-cleaners for high efficiency collector. While we have the high efficiency collector, for this case, it is this gravitational settling chamber we can use as a pre-cleaner for that high efficiency collectors. Okay, so these are the some of the applications, some of the field where we can apply the gravitational settling chamber. So next we will discuss about the cyclone separator. Cyclone, why we are using this term cyclone? Cyclone means the spiral movement. Okay, so what will happen, you can see here, the from this outlet, inlet, the dirty gas is passing. While the dirty gas is passing through the enter into the instrument, some of the, it will having the spiral movement. Here you can see the spiral movement it will have, cyclone like movement it will have. And after that, with the help of the gravitational force, centrifugal force also, that is utilized this, the separation of the dust particles. And after that, what will happen, the from the outlet, the clean gas we will get, the to some extent clean gas we can get. So for this cyclone separator, what we have here, the conical like section we have, you can see here the section is conical like, so that while the dirty gas will enter into the chamber, and it will move, it will have the spiral movement. By that movement, by the centrifugal force, the dust particles or large particles can be settled down. So settle down well, that is why it is conical shape. Understand? So here also I have seen, I have shown the instrument. You can see here the cyclone separator. Okay, the cyclone movement of the gas. So centrifugal force is utilized to separate the particulate matter. It can remove 10 to 50 micrometer particle size from the um, gravitational settling chamber. Generally, we remove the large particles like 50 micrometer, around 50 micrometer size. And for this case, we can remove the range of the particle size, that is from 10 to 50 micrometer particle size. Whatever particulate matter we have, that particles can be removed by this chamber. Okay, now this is mostly used in the this cyclone chamber, cyclone separator, mostly used in the industries. Okay. Okay, now these are the some of the advantages and disadvantages we have. What are the advantages? That is, this is the low initial cost. require less floor area. For this instrument we require very less area. Okay, so it requires less floor area. Simple construction. The construction, if you see the construction of the equipment, it is very simple. Okay, and simple for the maintenance also. It can handle the large volume of the gas at high temperature. Very minded, this is another advantage we have. At high temperature, if the gas temperature of the dirty the gas or the gas molecules which is having the pollutants, so for this case this equipment can be used. Okay, they handle large volume of gas at high temperature. Okay, and no moving parts also we are having. So these are the some of the advantages we have. Now what are the disadvantages? Generally it requires large headroom. Okay, so the next is less efficiency for the smaller particles, as it is efficient for the 10 to 550 micrometer, but less than 10 micrometer the particulate matter cannot be removed, cannot be refined through this chamber. Okay, so this is one of the disadvantage. And also it is sensitive to variable dust load and flow rate. So these are the some of the disadvantages that we have for the cyclone separator. Okay, yeah, so application. Yeah, so where we can apply this cyclone separator, the control it can apply in the control gas borne particulates from industry, whatever the gases are producing. For that case we can use the cyclone separator, like cement, feed and grain processing, food and beverage processing. Okay, mineral processing, paper and textile industries, and woodworking industry. So all these, for all these industries, for whatever they are emitting the gas molecules, that gas molecules can be refined by this cyclone separator. Okay, used in recovery of the catalyst ducts in petroleum industry and reduction of fly ash emission. So fly ash, minded, fly ash also very harmful for any type of living system, for us also. If we inhale the fly ash containing air, so what will happen? We can have the asthma problem, we can have the allergic problem. Okay, so these are the some of the harmful effect of the fly ash. So generally nowadays what some of the industries what they are doing, and there are so many research work also going on to reduce the emission and to reuse the fly ash. Generally this fly ash is using in the building of the in the road. Okay, while they are making the roads, and they are using the fly ash. Okay, so thus the fly ash can be reused, and we can thus reduce the fly ash emission. So this reduction, for the reduction of the fly ash emission, for this also we can use a cyclone separator. So these are the some of the application fields that where we can use a cyclone separator. Okay, now we have the electrostatic precipitator, very important, electrostatic precipitator. So what is the working principle? It works on the principle of electrical charging of particulate matter, that is negatively charged. Generally particulate matter we assume that that is the negatively charged, and collecting it in a positive charge surface. 99% efficient. You can see 99% efficiency. Efficiency is very high, and it can remove the particle size which is range of 0.1 micrometer to 1. That means very small particles can also be removed by this electrostatic precipitator. And that's why this electrostatic precipitator are very important, okay, to control the air pollution. Okay, what are the 6 major components? A source of high voltage, discharge electrodes and collecting electrodes we need for this electrostatic precipitator, the inlet and outlet for the gas molecules, a hopper for the disposal of collected material, and electronic cleaning system also we need. We require for this electrostatic precipitators, and the outer casing to form an enclosure around the electrodes. Okay, so these are the 6 major components that we require for this system, for this equipment. Okay, now you can see the 2 electrodes. In between 2 electrodes we are having the field, electric field. So if the particulate matter will the air will passing through this electrode, what will happen? Particulate matters are negatively charged, so that will attracted by the positively charged the surface, and all this will be, you can see all this particulate matter will absorb by the positively charged surface area, and after that from the outlet we are getting the fresh water, the clean water. From this outlet we can get the clean water, understand? So in between these two electrode, one high electric field is applied, understand? So thus this is the working principle of the electrostatic precipitator. Yes, this is the working principle. Here we have the electrodes. Waste gas, we are passing the waste gas. What will happen? The particulate matter which is negatively charged particles will absorb by the positively charged electrodes, and all the particulate matter will absorb on the positive charge, and after all from the outlet the clean air we will get. So this is the working principle of the electrostatic precipitator. Yeah, this is the principles. Gas stream pass two electrodes. High potential difference is maintained. Out of two electrodes, one is discharging, collecting. Potential of 100 kilovolt are used. Ionization creates active glow zone called corona, and gas ionization is dissociation of the gas molecules. Yeah, so these are the some of the advantages and disadvantages we have. So what are the advantages? That is high collection efficiency, particles may be collected dry or wet, can be operated at high temperature, maintenance is normal, few moving particle parts we have. And what are the disadvantages? High initial cost, this is very expensive, okay. Require high voltage, collection efficiency reduced with time, space requirement is more, possible of explosion during the collection of the combustible gases or particulates. So if we use the combustible gases, if we have the combustible gases or particulates, for that case we cannot use this electrostatic precipitator equipment, as there will be a chances of the explosion. So these are the some of the disadvantages, but main advantage of this precipitator for this equipment is it can remove the particles in between 0.1 micrometer to 1 micrometer, right? So very small particle can also removed by this electrostatic precipitator. This is the special benefit of using the electrostatic precipitator. So where generally we are using, that is in the cement industry, cement factories, the pulp and paper mills, steel plants, non-ferrous metal industry, chemical industry, petroleum industry, the carbon black industry or electric power industry. So all these industries are using the electrostatic precipitator to refine the air, whatever air they are emitting from the industry. Okay, so this is the today's all about the today's topic. Now for the quick review, I have given one question, that is, what are the disadvantages of the gravitational settling chamber? For that you will have the 10-second time. So your time starts now. You have to remember, you have to memorize that, then you can answer the question. Yeah, your 10-second time is over, and you are absolutely right. The answer is, it what are the disadvantages? It require large space, gravitational settling chamber. That means we have to reduce the velocity, and for that we should require the large space. The gravitational the chamber will be very much large. The less collection efficiency, only larger size. Okay, the 50 micrometer particle size, if we have, that particle will be removed by this gravitational settling chamber. Okay, so these are the some of the disadvantages that we have for this gravitational settling chamber. Okay, so again, this is the recapitulation. So we have discussed today the control of air pollution, the some of the equipments we have seen, the advantages and disadvantages, and also the working principle. From this portion, generally the you can ask, like, what is the working principle of gravitational settling chamber, what is the advantages and disadvantages of this cyclone separator. Okay, what are the fields, what are the industries that we can apply the electrostatic precipitator. So these are the some of the types of questions that you can have from this portion. Okay, so please students, follow the classes regularly, and submit the assignment whatever I have given just in time. Okay, so thank you students, and see you in the next class.